So the first part of the experiment is over. Now we are going to the second part. The second part is standardization of link solution. So the link solution which is taken for this experiment is a potassium permanganate whose strength is not known. And also we cannot prepare a standard potassium permanganate solution. See, there are certain conditions to prepare a standard solution. Any deliquescent salt. What is a deliquescent salt? Anybody can answer? What is a deliquescent
The
salt?
salt can absorb water from the atmosphere.
Water. What is the opposite for that? What is opposite for that? Anybody knows? See, the substance which can absorb water molecules from the atmosphere is called deliquescent substance. The substance which can lose its own water and can become dry. What is the name of that water, that substance? It is called efflorescent substance. Efflorescent. See, actually, this deliquescence or efflorescence, this depends upon the vapor pressure of water in that substance. I will explain that when we come to the third year. Right. So, normally for deliquescent substances, you cannot take the accurate weight like sodium hydroxide, like this potassium permanganate, because their weight will change when you are weighing. So the weight that you have taken will not be very accurate. You may say that the weight is accurately taken, but when you dissolve, the weight would have been different. So you cannot be sure about the strength of the standard solution. Therefore, the potassium permanganate standard solution cannot be prepared. So the given potassium permanganate solution is taken in the burette with the usual precautions. What is this usual precautions? You take the burette, first wash thoroughly, and then take a small amount of potassium permanganate and rinse the burette, because the washed burette will contain water droplets on the walls of the burette. So when you pour the potassium permanganate inside the burette, these droplets will dilute the solution and the strength will change. Therefore, before filling the burette with the potassium permanganate solution, you have to rinse the burette with the solution which is to be filled. You take a few ml of potassium permanganate and take the burette in the horizontal position and rotate the burette so that the solution touches all parts of the walls of the burette and all the droplets are simply washed off, which is completely rinsed by the potassium permanganate. So this is the usual precaution. And fill it a few ml above the zero level and then open the tap and bring it down to the zero level, and the zero level fixing should be done with the upper meniscus without any parallax error. Suppose if you look at the burette level in the above the eye level or below the eye level, you will experience a parallax error. So you have to take care that the parallax error is not there and the burette is thoroughly rinsed, and also the mark is upper meniscus is coinciding with the zero mark, and these are all the usual precautions to be taken. Then you are taking a conical flask and you are given a graduated pipette. Graduated pipette means that pipette will contain the marking from 0 to 9 ml. Actually, that pipette is called 10 ml graduated pipette, but the volume is not 10 ml because after 9 ml, the pipette is not graduated. Therefore, we cannot be sure that the solution below the 9 ml to the tip of the burette is exactly 1 ml. Hence, you can measure any volume from 1 to 9 or 0 to 9 using the graduated pipette. So use that pipette and pipette out 9 ml of the standard oxalic acid solution, which you have prepared already. You pipette out 9 ml of the standard oxalic acid solution into a clean conical flask. So the conical flask should be very clean, and take it into a clean conical flask, and then add 1 test tube full of dilute sulfuric acid. What is the need for adding the dilute sulfuric acid? Only in the presence of dilute sulfuric acid, potassium permanganate will act as an oxidizing agent. Now, the contents of the conical flask are heated to bearable warmth. Why it is heated to bearable warmth? Anybody? Why it is heated to bearable
The
warmth?
oxalic acid.
Yeah.
The oxalic acid react with KMnO4 at elevated temperature.
No, that is not the reason actually. Think and tell me. Have you ever done this oxalic acid that came for titration in your schools? See, initially the disappearance of a pink color will take time. But as the time goes on, as the titration goes on, then the disappearance will be very fast. What is the reason? What is the reason? Anybody? Okay, I will tell you. Actually, oxalic acid KMnO4 reaction is an auto-catalyzed reaction. Auto-catalyzed. Auto-catalyzed reaction, one of the products formed is a catalyst. In this reaction, the Mn2 plus ion is a catalyst. So, initially, the system is not containing Mn2 plus ion. But when titration goes on, more and more Mn2 plus ions are produced, which are the auto-catalyst for this reaction. Hence, initially the reaction is slow, but finally the reaction is fast. That is the reason. And the reason behind heating the content is this Mn can form coordination complex with oxalic acid molecules. If a coordination complex is formed, which is not used for the oxidation, so your titer value will be wrong. So the stability, we are going to decompose the complex. The complex can be decomposed at 60 to 70 degrees centigrade. Therefore, when you heat the content, the complex formed by the oxalic acid with Mn manganese, the complex will be decomposed and the oxalic acid will come out. This is the reason. So sulfuric acid is added to it. The contents are heated to bearable warmth. You cannot measure the temperature of these contents with a thermometer. That much accuracy is not needed. Bearable warmth. Normally, you can think of the temperature of a tea or coffee. That is bearable warmth. The temperature which you can bear, that is bearable warmth. So you are going to heat to bearable warmth. Normally the bearable warmth will come around 60 to 70 degrees centigrade, and then it is titrated against the potassium permanganate taken in the burette, and you are slowly titrating, and the end point is the appearance of a pale permanent pink color, and the end point is noted. So up to this you might have done in schools. Then what you would have done in your schools, you might have washed everything, and again you might have pipetted out the solution, and again you titrated with the refilled burette, and again you might have found out the end point, and you repeated the titration till you get the concordant titer value. This is the usual procedure. Actually, this method is called a semi-micro method, but we are going to do the experiment in micro method. So in micro method, what we are going to do, we are not going to wash the conical flask. So what is remaining in the conical flask, let it be there. So there is an appearance of a pale permanent pink color. By this time, you will be having the conical flask with a solution pale pink in color. Don't pour it out or don't wash it off. Note down the end point and then pipette out of 1 ml of the standard solution again into the same conical flask. 1 ml, just 1 ml is taken. Because you are using the graduated pipette which can measure any volume from 0 to 9 ml. You can take just 1 ml of the standard oxalic acid solution which is added to the conical flask which is already containing a pale pink colored solution. When you add the 1 ml of oxalic acid into the conical flask, immediately the color will vanish because excess oxalic acid is now present. So the color will vanish and you are going to continue the titration. You are not going to fill the burette again with the potassium permanganate. You are continuing the titration. You drop wise drop, you add, and again there will be appearance of a pale permanent pink color. Note down the end point. Again add 1 ml of the standard oxalic acid solution into the same solution. Then the pink color will vanish. Again you continue the titration until another appearance of a pale permanent pink color. Such titration has to be continued up to 15 ml of the oxalic acid. So 9 already taken, plus 1, plus 1, plus 1. So you have to titrate for 7 times with the same solution and with the same burette, with the same continuation of the readings noting down. You continue up to 15 ml. You will get a tabular column like this. Look at the tabular column. Whatever I have written here is very important. Above the tabular column, you have to write a titration 1, which is very important. And what is the titration 1 about? That has to be mentioned. It is for the standardization of KMNO4 solution. And in the next line, you have to write what are all the things titrated. Standard oxalic acid solution versus potassium permanganate solution. You have to put an arrow mark like this, which is a self indicator. If at all any other indicator is used, you have to write that name here. It is a self indicator. And the tabular column, the first column is serial number, second column is volume of oxalic acid taken, third and the fourth column burette reading, and this is initial reading, this is final reading, and from this you are going to find out the volume of a KMNO4 solution and then the strength of KMNO4 solution. So first we have taken 9 ml, initial burette reading is 0.0, final burette reading is 8.7. So the volume of a KMNO4 solution is 8.7. So then 1 ml is added. Now the volume of oxalic acid is 10 ml. Initial reading is 8.7. Final reading is 9.7. So volume of KMNO4 corresponding to 10 ml of oxalic acid is 9.7. Again, 1 more ml added. Now the volume of oxalic acid is 11 ml. Initial reading 9.7. Final reading 10.6. So the volume of KMNO4 corresponding to oxalic acid of volume 11 ml is 10.6. So this is how you are continuing. Look here, unit is very important. Actually the burette reading, it does not have any unit. It is simply a reading. This is only the volume of KMNO4 is having unit ml. So unit is very important. Either you write the unit here or you can write the unit in common here itself, volume of oxalic acid in ml or volume of KMNO4 in ml. Then you need not write the unit here. But in all tabular columns, unit is very important. Actually here I have not written the unit, it has to be normal n. So look here, the first calculation, strength of oxalic acid multiplied by volume of oxalic acid divided by volume of KMNO4. V1 N1 by V2, because N1 V1 is equal to N2 V2. So N1 is known, V1 is known, V2 is known, N2 is calculated. So you are doing the same calculation. See, look here in the first thing, 9 ml of oxalic acid, 8.7 ml of potassium permanganate. Second calculation, 10 ml of oxalic acid, 9.7 ml of potassium permanganate. Third one, 11 ml of oxalic acid, 10.6 ml of potassium permanganate. So this is how it is continued for all the 7 readings, and all the 7 strengths are calculated, and these strengths are put over here, and the average of all the 7 is taken as the strength of the KMnO4, which comes to 0.0537 normal. Actually, I have not written the unit here. You write in your observation notebook, N, which is expressed in normality. So with this, we are completing the first titration. So the first titration is over. See, the molecular weight actually includes the water of a crystallization. There is a water called crystallization. I have already, in the beginning itself, I have told you that we are provided with oxalic acid crystals. I want to ask you one question. What is the color of copper sulfate? Anybody who knows the answer can answer. What is the color of copper sulfate?
Blue color.
Actually, the answer is wrong. If I ask what is the color of a copper sulfate, you should say it is colorless. The reason is anhydrous copper sulfate is colorless. The blue colored copper sulfate is a copper sulfate pentahydrate. Copper sulfate containing 5 molecules of water, which is the water of crystallization. The blue colored copper sulfate crystal is stable only with 5 molecules of water of crystallization. Similarly, here oxalic acid is also containing 2 molecules of water of crystallization. Actually, if you note down, the ferrous ammonium sulfate is containing 24 ml of water of crystallization. 24 ml of water of crystallization. So it is very important to know the molecular weight along with its water of crystallization. So we are going to see the next part of the experiment. So the second titration, which is called the estimation of oxalic acid. So now the potassium permanganate is standardized. That is why the statement starts like this. The standardized potassium permanganate solution is taken in the burette. So previously it was not standardized because whose strength was not known. But now you have found out its strength. So the standardized potassium permanganate solution is taken in the burette with the usual precautions. The given solution of oxalic acid is made up to 250 ml using a standard measuring flask, which means the solution to be estimated will be given in a bottle, a numbered bottle. That bottle will carry a number. When you come into the laboratory, you will be given a number. That number is not your register number, which is your seat number. We will allot seat for every one of you in the laboratory. The same number will be found on your table, work table, and the number will be found on your cupboard also. That cupboard is allotted for you, inside of which you have to keep all your belongings, and you should bring a lock and a key and you have to lock it. For the whole 3 years of your course, that is your table and that is your cupboard. You have to empty everything and hand over the cupboard only at the end of the 3rd year. So that is the number. That is your seat number. You will be given solution in a numbered bottle and you should check whether the number on the bottle and your seat number are the same, because each number will be given a different solution with a different answer. The answer will not be the same for all. Actually, while preparing for the practical examination, we will change the concentration of the solution in every bottle and we will note it down and we will do our own calculations and we will be accurately knowing the weight of oxalic acid present in each bottle. Only with that knowledge only we will be calculating the error of your calculation and your performance in the practicals. Therefore, the solution is given in a numbered bottle and that solution has to be made up to 250 ml. So transfer the solution into a 250 ml standard flask using a glass rod. As usual, wash the bottle for more than 10 times with a minimum quantity of the water, and every washings should be poured into the standard flask, and finally water has to be added and the mark and the level of the solution should be aligned, and you have to make it up to 250 ml using the standard measuring flask. So you are going to pipette out 9 ml of the made up solution into the clean conical flask. As usual, 1 test tube full of dilute sulfuric acid is added and the contents are heated to bearable warmth and the contents are titrated against the standardized potassium permanganate solution taken in the burette. Again, the end point is the appearance of a pale permanent pink color. The same procedure is repeated for every addition of 1 ml of the given oxalic acid solution to the conical flask as usual. Then the burette readings are tabulated. The strength of the given oxalic acid solution is calculated, from which the quantity of the oxalic acid is found out. Look here, I'm going to share the second tabular column. Yesterday I did the whole experiment and then came out with this answer. Look here, the titration 2. Above the tabular column, we have to mention titration 2, which is the title is estimation of oxalic acid. Estimation of oxalic acid. And then what are all the things titrated? This should be very clearly mentioned. The given oxalic acid solution versus standardized KM104 solution, an arrow mark self-indicator. Similarly, serial number, volume of oxalic acid, burette reading, initial, final, volume of KM104 solution, strength of oxalic acid solution. Look here. So first 9 ml is taken. Endpoint was 9.5, volume 9.5. After the addition of 1 ml to the same solution, now the content is 10 ml. Endpoint is 10.4, 11 ml, 11.5, 12 ml, 12.7, 13 ml, 13.4, 14 ml, 14.5, 15 ml, 15.6. Again, the calculations. You know the strength of KMnO4 calculated from the first part of the titration. It is 0.0537 into volume of KMnO4, that is the titer value 9.5, divided by volume of oxalic acid taken 9. This is the answer. For the second titration, 10.4 is the titer value, 10, which is the volume of oxalic acid taken, the answer. So you are writing down all the answers and you are taking the average of the answers, which is the strength of the oxalic acid. So the final part, so the strength of the given oxalic acid solution is found out. It is 0.0560 normal. Then the amount of oxalic acid present in 1 liter of the solution is calculated. It is a strength multiplied by equivalent weight. So in 1 liter of the given solution, 3.5280 gram would be present. Then the amount of oxalic acid present in 250 ml of the solution is calculated because you have made it up to 250 ml. So in 1 liter, 3.5280 gram is present, divided by 4 is 0.8820 gram. So this is the quantity of the oxalic acid present in the whole of the given solution. Why whole? You have taken the entire solution what I have given and made it up to 250 ml. So what is present in the 250 ml is what actually the whole I have given. So it is 0.8820 gram. So you have to write a result. See, everything is very important. You have to write result. Somebody will write a report. It is not report, it is result. For quantitative analysis, you have to write result. For qualitative analysis, you have to write report. Because in qualitative analysis, you are going to find out what is the nature of the substance. Suppose salt analysis, you are giving a report. You do systematic analysis of the salt and you finally say the given salt is containing the cation lead, the anion sulfate, which is not a result, which is a report. It is a report. But in the case of quantitative analysis, you do the calculation and you are coming out with the result. So for quantitative analysis, the experiment should end in result. For qualitative analysis, the experiment should end in report. So these are all the things you should know. So I will disconnect now and please rejoin. The 40 minutes over.